So the conversation I wanted to have with you is about artificial intelligence and healthcare. At the same time, I wanted to also discuss some of the complementary technologies that will play a role in patient care. So just to give you a little bit of background on the company I work for, the company is United Health Group. A lot of people in the US and across the world don't know who we are, but it's a company that has two basic platforms. It has a benefit platform, which you know as insurance, as payers, and it has a healthcare platform, which you know as pharmacy service, care management services, clinician services, et cetera. So that's who we are. We have a company that basically has healthcare services and a company that has benefit services. And we're, as a company, across the spectrum and embedded in the healthcare life cycle. So I'm not going to bore you with that, but we do a lot of work in all the areas you see. I run a team of about 124 people, of researchers and developers, and we're focused largely on artificial intelligence, but graph databases, genomics, IoT, and a few other technologies. So I wanted to start the conversation with where we see the future, because it's really important to understand that in the context of how we see artificial intelligence and also in the context of where we see patient care going. So the major point on this slide is twofold. We believe the end game is around ambient intelligence, that it's around intelligent objects, it's around the infusion of AI, it's around AI as a general purpose technology. And as a general purpose technology, it's like any GPT. It will improve over time. What we see today is not what we'll see 10 years from now. But we also see the modalities changing. So we see the immediate modalities to be around conversation. And when you think about that, if we go back decades, we had these modalities of character interfaces, and then we saw some more richer interfaces, and then we see mobile today. But I'm suggesting that conversation, much as you saw from the last speaker, that will be the modality of our future. We will be using voice, and we're already seeing that today, as the modality of our interface. And that will require natural language processing embedded with deep learning. It'll require a lot of aspects of artificial intelligence to make that conversation actually seem real, and it'll require some more inventions at the same time. The state of AI adoption in the healthcare, you see some numbers there. We as an organization, and I'm going to take a step back, we have a framework by how we look at artificial intelligence within our own company. And we look at it in the level of waves. I don't know how many of you were present in one of the speakers early this morning who talked about the notion of doing AI for the last 50 years. I may have said 50, 40, whatever the number is, but that we've been doing it for a long time. There's clearly a lot of truth there, but there's also vagueness there. So the context I wanted to give you is simply as follows. We've looked at AI in terms of wave 0, wave 1, wave 2, wave 3. Wave 0 we define as basically the kind of artificial intelligence that we saw in the 90s, pre-90s, largely rules-based, largely a lot of statistics or statistician type and math. And the iconic display of that wave 0 was probably IBM's Deep Blue, when it beat Garry Kasparov as the premier world chess champion. That was probably the most iconic display. And a lot of different companies had technologies. Wave 1 came afterwards, and wave 1 is when we started seeing more math. We saw the arrival of machine learning. We saw the arrival of big data. And we saw natural language processing advance, and we saw significant advancements. And probably the most iconic display of wave 1 was IBM's win at Jeopardy. Let's make sure we understand some of the distinctions in these waves. One distinction in 0 and 1 is 0 today, a lot of us would not describe that as artificial intelligence, but that, you argue, is a value statement. The wave 1 requires a lot of heavy lifting, a lot of engineering to actually build those systems. Then if we look at wave 2 is really the application, the adoption of deep learning. This is where the instantiation of backpropagation, the actual deep neural networks, not just the simple neural networks, but these really deep neural networks to solve some of the complex problems. This wave 2 is really what's introduced this problem space around explainable AI, which I'll get into in a moment as well. So what's my point? The message of describing it this way is that I think it's inaccurate or misleading to say that we've been doing AI for a number of years. Because what's misleading about that would be the same as saying that we've been using computers for the last 50 years. It's, of course, a true statement, but the computers we use today are different than the computers we used in the 1950s. It would be the same as saying that our physics today is the same as physics in the 1700s. There are substantial differences that warrant thinking about this differently. So that was one major point, to think about AI in these waves. The second major point is that artificial intelligence, we believe, is a general purpose technology which will have profound ways in the transformative nature of healthcare. It will literally transform how we work, play, and live. And one of the attributes of a general purpose technology is that. Another attribute of a GPT, a general purpose technology, is that it will improve over time. So we believe with the volume of research being poured into artificial intelligence, you saw that with speakers today, that we'll see something much different than we see today. So lots of investment going in AI. A lot of it in the healthcare is around operations, automation, and administrative tasks. You see some numbers there, whether it's eliminating fraud, phantom providers, bad claims, whatever the issue might be. But I think this slide, if you pay attention to it, is an interesting one, because what it's trying to communicate is there are three ways you can think about artificial intelligence. And I think the way you think about it really sets the stage not only for your imagination, the art of what's possible, but it sets the stage in the steps that you will undertake in your own organizations, whether it's the financial industry, whether it's the healthcare industry, because we could easily change the slide to reflect the specific industries. But notice what we're articulating. We're saying that one way we can think about AI, and I'm not defining AI when I say this, I'm really talking about its use cases, its adoption, its value as a change agent for your organizations. One way we can think about this is to think about very specific use cases. And by the way, we should do that. We should have very specific use cases that represent our early adoption, represent our early successes, whether that's detecting more fraud, whether that's taking friction out of the healthcare system, whether that's doing better diagnostics. And then the second scenario is one where, yeah, let's build better products, whether that's diagnostic products or whatever. I actually love the last talk, but don't agree with one point in the talk, which is that there's no evidence that AI will replace oncologists or replace radiologists. There's just no evidence of that. In fact, just the opposite. The evidence tells us historically and today that AI will be a tool and that the radiologists of tomorrow who are effective will be using artificial intelligence. It will be complementary, because it's a mistake to think that all that radiologists do is detect tumors and look at X-rays. They do a lot more than that. And that's a topic for another day. But the point is that we do see a complementary role of how clinicians and how artificial intelligence play together. If you haven't, there's an interesting story which is a sort of a prelude to this. If you go back in time when IBM played Garry Kasparov in chess and beat him very handily, there was another story that didn't get a lot of press. And the other story is that Garry Kasparov formed another chess competition post his loss called Centaur Chess. And in that scenario, what he did, again, this is still wave one of AI. What he did in this next scenario is he created a competition where you could come and play. You could come with a computer. So you could come by yourself, or you could come paired with a computer. You could come with a supercomputer. You could come with PCs, your choice. What was interesting was that the winners of that Centaur Chess, one of the tournaments, were a couple of guys who were not grand champions. They're pretty good chess players, of course. And they didn't have a supercomputer. And by the way, there were grand champions who entered the competition. But these two guys won with PCs. So the point is that the human-computer interplay can have a very powerful effect. Now, if we were to play that same tournament today, because of wave 2 of AI, the computer would win all the time, because chess is a fairly simplistic game. And I don't know if I said it already, but AlphaGo and Google's demonstration there was a great example of of wave 2 of AI. So, back to the slide. The second message you'll see in the middle there is that we can also use AI to really make better products. And in order to do that, if you haven't seen the article from Wired Magazine on the AI flywheel, take a quick look at it. You can just search Wired Magazine plus AI flywheel. But it really points out a lesson learned that Amazon learned early on, which is that in order to really get the power out of artificial intelligence, you really need to have not only this virtuous data cycle, but this AI flywheel where you're using data to make your products better, to make your experiences better. More importantly, you're not siloed. You're not taking the best practices from a group that happens to be in Germany and not leveraging it with a group that is in Cleveland, Ohio. So this AI flywheel I think is a very significant concept in terms of how you organize, how you share, and how you do that with technology. So the second message there is that, yeah, we can look at AI that way as well. But the third one is what I would suggest we should all be thinking about, is how can we, if I were a financial services company, how do I reinvent transportation for the future? If I'm a healthcare company, which we are, how do we create a platform that really provides personalized medicine, takes friction out of the system, and actually makes people healthier? And of course, brings down the cost of healthcare. So I think our ambitions can be high. I think that we can actually use artificial intelligence to do more than what we're doing today. And of course, I do believe some of that's going to require, I know some of that's going to require some of the inventions that have yet to materialize. If you've been tracking deep learning, some of the great computer scientists like Hinton and others, they're making bold statements that, and you'll see this in articles as well, that have we hit a wall with deep learning? And I would argue that no, we haven't hit a wall because there's just a tremendous amount of problems that we still need to solve, and we can do that with the technology off the shelf right now. But we're going to be able to do more as more invention occurs. I wanted to cover this notion of big data and small data. We all know about big data, and we all know that this wave 2 of AI, deep learning, really is it's starving for data. It needs data. And I'll talk about that a little bit more. But I wanted to bring home this notion of small data because I'll give you an example. We know, because of our data and because of working with partners, we know that for certain patients, for certain members who have certain chronic conditions, that their outcomes will be better at provider A versus provider B. The context of small data says that, well, maybe we're talking about the state of Connecticut. Maybe we're talking about a small region in the state of Connecticut. Maybe we're talking about 10 oncologists if it was cancer. Maybe we're talking about 5 patients. That's small data. So how do we, with that kind of data set, be able to steer people to the best outcome? And I'm just simply articulating we can do that. But this notion of small data is becoming increasingly important because it's less noisy, meaning it's higher quality. But just to put that into your mindset, big data, small data, they'll play together. And even though I say small data, we still have a lot of it. It's just not as big as the big data. So we're still using the math, we're still using the algorithms. The second message of this slide is simply to illustrate that there's a lot of data that tells us that the data that we primarily collect today, the clinical data, is important, but its effect on the outcome, its effect on preventative care, its effect on health is good, but not where we want it to be. If we add in genomics data, we can do a lot better. You see the percentage jump significantly. If we add in exogenous data, which is all of the behavioral data, we can do even better. So that's what we're also looking at, is to be able to use all 3 of these types of data to really make people healthier. The advantages of AI are numerous, and I won't bore you with that, but the real message on this slide is that we've moved away from rules, so we're abandoning there are cases and there are certain problems where we still have to do some of this wave 0, but we're aggressively doing more wave 1 and more wave 2. And I'll give you an example of this. But we also see the interactions and the scalability much different with AI than what we did before. I'll walk through another example, but I think I've covered the point that we do believe that the level of care, and you saw that with the example just previous to this presentation, there's a ton of examples. There's a ton of startups. I mean, when you think about the startup world, when you think about the FAMGAs, the Facebook, Amazons, Microsoft, Googles, they sort of have an asymmetrical attack against incumbents. And that asymmetrical attack means that they, because of how investors view the upside of their companies, they have more capital in many cases to spend. And there's a race that I think we're all aware of on AI talent. Now I'm going to take a contrary view on this race for a couple of reasons, and I'll give an example of this. So the race, of course, is articulated that it's for AI talent. I would argue 2 points. That the race is actually around ambient intelligence, which is where we're going. I'll come back and explain that very quickly. But it's also, if you think about sports as a metaphor, as an analogy, teams, whether it's in basketball, football, whatever, they do these drafts. Why do they do these drafts? They do them to get the best talent. But the reality is, as you know, is that they may have 5 #1 draft picks, but they don't all turn out to be winners. And the same thing is happening with the race for AI talent. Companies that are building the underlying technology, which is not us, those are the Googles and the Facebooks and the Amazons, those companies really are arguably doing a NBA draft, trying to find these stars who will be the next inventors of some really great technology. I mention that because on the other side of the coin, there's a tremendous amount of talent coming out of the universities. They may not be the #1 in their class. Maybe they didn't get an 800 SAT score. Maybe they got a 750. That's not bad either. But the point is that there's a tremendous amount of talent that we are finding that we can tap into from a variety of universities across the nation. So I would assert there's a mythology around the shortage of AI talent. There's a shortage of #1 draft picks. There's not a shortage of top 10 draft picks. We've been able to do a lot of work around multi-disease prediction. Prior to wave 2, a lot of our multi-disease prediction is being able to see the patterns when someone has diabetes and a coronary affliction at the same time. To be able to actually use deep learning to improve the prediction models is a significant achievement for us. And that's something we've been doing with diabetes and so forth. And the point is, not only can we get the prediction model better, but with deep learning, we've been able to remove the SME. Not that we've removed them completely, but we've reduced the amount of feature engineering and therefore reduced the amount of reliance that we have on some of the clinicians. The other point I wanted to make is we do see 3 worlds that are coming together to create this ambient intelligence world that I've talked about. Those 3 worlds are the world we live in, which is the physical world that's increasingly becoming instrumented. It's the world of people, where it's also becoming instrumented because of our use of social media, because of our use of wearables. And it's also the world of systems, the things that you and I build. So those 3 worlds are coming together to create more powerful opportunities in terms of what we build. This picture is a little bit complex, but it's simply trying to show the interplay between a multitude of technologies. So when I talk about wave 2, NLP with deep learning is wave 2, NLP without deep learning is wave 1, but we see the play of robotic process automation, NLP, blockchain. We see all of these technologies, and I could spend an hour on this slide, really coming together to improve patient care. So this was all a lead up to get you to this page, because I do think this is where we're headed. We're headed to this ambient computing world where we do have, and by the way, this is going to be fueled by cloud. It's going to be fueled by mobile. It's going to be fueled by 5G. It's going to be fueled by a lot of technologies that are in play today. But at the heart of those technologies will be the use of artificial intelligence to get to a world that begins to sense our context and react accordingly. And I know it sounds a lot like science fiction, but we're not that far away from this world today. So when I talk about ambient intelligence and care, it's more than IoT. It's IoT infused with artificial intelligence. It's the ability to know that you've fallen down in your house and the ability to engage with you, a little bit like you saw that last video, but the ability to engage with you and to if you're not responsive, to call a care agent. So if you think about a lot of what we do today in terms of clinicians doing preventive care like nurses by calling people up, we can do a lot better if it's automated and that we become aware. So a new phase of AI is coming. I talked about wave 0, 1, and 2. The Book of Why, if you haven't read it, I encourage you to pick it up. It really does talk about the wave 3 and what's coming. Doesn't use my language, but that's irrelevant. But Daniel Pro, who wrote that, is a brilliant guy, and I encourage you to read it. So we think this wave is coming fast and furious, and it's fueled by artificial intelligence. So thank you very much.